Welcome. My name is Boris Paskiver. I am a software engineer, agile consultant, online educator, and author based in New York City. And I'm really excited to introduce you to the Pandas library. Over the course of the next hour, maybe hour and a half, we'll be walking through a sample data set, seeing what we can do with Pandas. So this is really great for Excel people, people who are used to working with graphical spreadsheet applications like Excel or perhaps Google Sheets or numbers, and seeing how Pandas can help expand on those data analysis operations. The simplest way that I can describe Pandas is Excel on steroids. Let's take a step back before we dive into our data set and talk a little bit about what Pandas is. Pandas is a data analysis library. It's a toolkit for data, and it's built on top of the Python programming language. Now, the Python language itself is about 30 years old. I think it came out around 1991. The Pandas library itself is about 10 years old. It began as a pet project by a man named Wes McKinney. He was working at, I think, a hedge fund or some kind of financial management firm. And he found that it was increasingly difficult to work with financial data, all the things that we need to do with data in our everyday data analysis, whether it be identifying duplicate rows or cleaning missing values or joining data sets together, sorting values, identifying broken values, working with text data, splitting text data up, removing white space, all of these common operations that pretty much comprise the majority of data analysis, the part of getting data into the right shape in order for you to be able to find the story from it. All those data analysis operations he found were not particularly easy in the solutions available to him. So he built Pandas to solve that problem. Eventually, it became an open source solution. Lots of developers came on board, started contributing to it. And now it's a huge data analysis library. In fact, Pandas is so popular today that it's largely credited for the growth of the entire Python programming language as a whole. The way trends are going, Python is on track to become the most widely used programming language in about a year or two, according to things like Google search trends. And most of Python's huge growth and popularity has been attributed to the role it plays in the data science ecosystem. And Pandas many times is sort of the nucleus of that, the epicenter of that. Python is popular for a wide variety of these data applications, whether it be machine learning or natural language processing. And Pandas is kind of the toolkit that sits in the middle that allows you to get the data into the shape that you need it to be in for an analysis or to feed it into any of these additional tools that you need to work with. All right, so let's get into the actual heart of this live stream, the heart of this tutorial. We're going to be walking through a sample data set. I want to introduce you to that data set right now. So hopefully you can see my screen. This is the Jupyter Notebook, or the development environment in which we're going to be writing our code tonight. What's really great about Jupyter is it has this trial and error approach to writing your code. So you can write any code you want in any of these cells, you execute it, and the notebook gives you immediate feedback. So as a simple example, if I type in 1 + 1 and I execute it, you can see we're going to get 2 below. And that's really great when we're analyzing something like a data set, because we can try a different snippet of code, see the result, see the output, see if it fits what we're looking for, and if not, we simply modify the code, rerun it again. There's no need to save files or to run Python from the terminal. We just keep this kind of ongoing feedback loop going in order to practice. And in the spirit of being on Twitch, I've decided that we're going to be analyzing a video game sales data set. So this data set is taken directly from Kaggle.com. If you're unfamiliar with Kaggle, Kaggle is a really great site for finding all sorts of different data sets. In addition to the actual data sets themselves, you're going to find people's analyses of them. So if you'd like to explore how other people think about a problem, it's a really great place to start. And as I scroll here, you can see all kinds of great data sets are available. All space missions from 1957, heart failure prediction, women's international football results, top chess players. There's all kinds of these great statistics. Some of them are totally random. Some of them are public government statistics, all kinds of great stuff. And in the spirit of being on Twitch, I searched for a video game data set, and I found this video game sales data set right here from Gregory Smith. And that's what we're going to be working with and analyzing. All right. So I have my Jupyter notebook right here, and it's in the exact same folder as my CSV file, my comma separated values text file that's storing my actual data. So let's begin by importing Pandas and simply importing this data set, this plain text, into a Pandas data structure. And if anybody watching here is more of an Excel person who doesn't have a lot of familiarity with Python or programming, don't worry. I'm going to try to keep things as non-technical as possible, just giving you a big picture overview of what's going on here. All right. So in here, in my Jupyter notebook, I'm going to begin by importing my Pandas library. There's a wide variety of Python libraries. There's hundreds of thousands of them. I want to specify that I want to use Pandas. So I'm going to import Pandas. And I'm going to assign it a popular alias. An alias is just an alternate name we give to a library so we don't have to write out the full name later on. Pandas is 6 letters. It's a lot to type. People make mistakes. So we commonly give it the alias of PD. So here I'm going to write import Pandas as PD. And once I execute this cell, Pandas is imported and I can reference all of its available functionalities straight through PD. So let's begin by showing you how we can import a data set. Pandas actually supports a wide variety of file types that it can import. I'm just going to show you a list here of all that is possible. Let's see here if I can get my autocomplete to show up. One more time, pd.read. Okay, it looks like my autocomplete functionality is off, but Pandas has support for data sets like CSVs, TSVs, Excel files, JSON, JavaScript object notation, SQL files, HDF files. It can even take things that you've copied in your clipboard and import them into a Pandas data structure, etc. It supports a wide variety of file types, and it can also save or export to a wide variety of file types as well. So here, the method I'm looking for, the functionality that I'm trying to use here is called read CSV, which reads a CSV file into Pandas, and our file in the same directory is called vgsales.csv. So I'm going to execute that, scroll up, and we're going to be exposed to our very first Pandas data structure, or our very first object. So for those who are not programmers, when I use the word object, all I'm simply referring to is this digital container of data. It's a specific data structure that is optimized for storing some type of data in some type of format. So the data frame, which we see here, this visual output, is effectively the equivalent of an Excel grid or an Excel table. It's a two-dimensional table of data. So it has rows and it has columns, okay? So the reason it's two-dimensional when I use that term, all that two-dimensional means is that there are 2 points of reference that are required in order to extract any single point from the table. So for example, let's say I wanted to get this value right here in the genre column of role-playing. How can I extract this specific value? Well, I can't simply say use the genre column because there's a ton of values in this column. There's actually 16,598 values in this column alone. So simply giving me the column, giving me one reference point is not enough. Similarly, if I were to say, give me the value from row 4, well, row 4 is not enough of an identifier either because there's a lot of values in row 4, rank, name, platform, year, etc. So in order to get role-playing here, I need the intersection of the row and the column. So because I need 2 points of reference, it is a two-dimensional data set. That's all that we mean when we talk about dimensions. It's how many points of reference we need to extract any point. So if you have a single column of data, it can be called a one-dimensional data structure because you only need 1 point of reference, the row number, in order to extract any value, all right? The number of rows and the number of columns is irrelevant. If we have 1 million rows and 1 million columns, it's still a two-dimensional data set. Let's take a quick look at what we have in this data set. We have the name of a video game. We have the rank it has on the list, and it looks like, in general, this data set is sorted by the total number of global sales, or millions of copies that this video game has sold worldwide. So it looks like Wii Sports has sold 82.7 million copies. We can see a breakdown by region, so North America, Europe, Japan, and other countries. And for each video game, we also have the platform or the console that it was released for, the year of release, which you'll notice is going to have floating point values. Notice that this is fundamentally a year of 2006, but it's stored as 2006.0. We'll talk about why that is a little bit later. We also have a genre of the type of game, the category, as well as the publisher. So in this case, Nintendo. All right. So once I see this data set, I can decide to modify it, modify its import, manipulate it, etc. So let's talk a little bit about these numbers we see on the left-hand side here. This is what's called the index. And the index is basically an identifier for each row. So if we don't specify any of our columns to serve as the index, Pandas will generate an automatic numeric index starting from 0. So here you can see the first row is assigned an index of 0, the second row is assigned an index of 1, all the way to the end of the data set. It's just some kind of identifier that can be used to mark a row. So Pandas is actually pretty flexible in that the index can be set to be any type of data type at all. So we can have our index or our identifier for each row be a piece of text, it can be a number, it can be a floating point. It doesn't even have to be unique. So our index values here, or our index labels, as they're sometimes called, can contain duplicates. Ideally, though, it's really great if the index does not contain duplicates, and it's also really ideal if it's sorted in some kind of order, ascending or descending. In general, whenever you have a collection of data that is sorted, there's a lot of optimizations you can apply to make extraction a lot easier compared to if it's unsorted. A good example is something like a dictionary in real life. The reason that it's really easy to find a word in a dictionary is because it's ordered, because you can cut the result set very quickly by simply moving in the right direction. It's the same idea here. So in general, it's a good idea to keep a sorted index. And in general, I would say, even though Pandas allows it, it's generally a good idea to have an index that is unique as well. So we have a rank column that I think would serve as a really good alternative index because it's basically serving the same purpose as the automatically generated index. It's just an identifier for each row. It's a unique identifier for each video game. So the way that I can set this rank column to be my index is by providing an additional parameter here to my readCSV method. A parameter is just a customization setting. It's some kind of option that I'm altering here. And all I'm going to say here is I want to use the rank column. So now we're going to re-import the CSV, and you're going to see it's going to set the rank column now as the index. So I'm happy with this result. So what I'm going to do is I'm going to take this result, which is a data structure. It's called the data frame in Pandas land, and I'm going to assign it to a variable called sales. A variable is just a name given to some kind of data structure in our program. Once it's assigned a name, I can have a reference point for it. So now we're not just referencing the CSV, we've taken its contents, we've loaded it into a data structure that is saved in memory in our program, and we can reference sales in any of these cells, and we can see the exact same data structure that we previously saw. And we can continue to perform all kinds of operations, calculations, things on it as well. So let's talk a little bit about attributes and methods. An attribute is a characteristic or a detail that is available on an object. It's something you can ask the object about its internal state, its makeup, its characteristic. So for example, there is an attribute called dtypes that is short for data types, and that's going to tell me the data type of every column. So what I'm going to get here is actually a different Pandas data structure that we'll talk about in a little while. It's called the series. But basically what we're seeing here is the column names on the left-hand side. You can see name, platform, year, come from our original sales data frame. And here we can see their data types. It's important to note that in Pandas, object means text or a string in programming terms. So the name and platform columns, for example, are holding text values. So your columns ideally should hold homogeneous values. What that means is they should be of the same data type. It doesn't matter what that data type is, numbers, integers, floats, strings, booleans, dates, as long as it's consistent. If your column holds different data types, it's usually an indicator that you're trying to store too many things in that single column. So here we can see the remainder of the columns are floats, which means they are numbers that have floating point components. So that's an example of an attribute. We just access it using this syntax of placing a dot followed by the attribute name. Let's now take a look at the complement to attributes, which are methods. A method is a command or a behavior that you can give to a data structure, to an object. So for example, what I can do is preview the first couple rows from the beginning of my data frame using a method called head. You can think of head as being at the top of the body. In a similar sense, we're looking at the top of the data frame. So I'm going to write the method name after dot with parentheses, and we're going to get the first 5 rows of the data frame by default. Now, if I click into here, and I hold my shift key and press tab, you're going to see that we have something called a parameter. A parameter, again, is a configuration setting or an option. We used one above when we, for example, provided index call right here. N specifies the number of rows that should be returned. And by default, it has a value of 5. So this syntax right here is equivalent to me actually feeding in 5 directly, or equivalent to me writing out the parameter name, the option name of n, and explicitly assigning it a value of 5. So these three pieces of code in this cell are identical as far as what they return. But of course, the benefit of n is that we can customize it. So for example, if we want to see the first 10 rows instead of the first 5, we simply modify that, and we get the first 10 rows of the data set instead of the first 5. There is a complementary method to head called tail. It does the inverse. It returns the last couple rows of the data frame. So for example, if I invoke the tail method, and it also has an n parameter that also has a default value of 5, if I don't explicitly provide a value, it's going to fall back on 5 and give me the last 5 rows of that data frame, of that table. And if I customize it, like something like n equals, let's say 8, I'm going to get the last 8 rows of this data frame. All right. All right, let's move on to our first kind of data analysis-like operation, which is going to be sorting values. So let's take a look at what we're working with right here in sales. Here's a preview. And as we mentioned earlier, the video games are sorted in order of their sales from the greatest sold to the least sold. Let's say I'm curious to sort this video game this video game data frame in alphabetical order. So I want to sort it by the values in this name column. So there is a method available on a data frame called sort values. It's going to be invoked in the exact same way that we just used the head method above. So we write the method name out. It's just an operation. It's a behavior. It's something we can tell the object to do. I want you to sort your values. And the first parameter we provide here can be the name of the column that we'd like to sort by. So here, in double quotes, because it's a piece of text, I'm going to tell Pandas that I want to sort this data frame by the values in the name column. So when I execute this, I'm going to get a brand new data frame, and you're going to see it's going to be sorted in alphabetical order ascending. And when it's sorting text alphabetically, numbers come first. In fact, I think this little apostrophe comes even before anything else. So you can see it's going to start with numbers. It's actually going to proceed all the way past the symbols. Here we have dot, and here towards the end of the data frame, you can start seeing we're getting to the U's and the W's and even these characters right here. So it's sorted it in alphabetical order. So it's what's called an ascending sort, and that is specified by a parameter here called ascending, which is set to true by default. All right. So this syntax right here is equivalent to this syntax right here. It produces the same result. We can customize this. So for example, if we want to sort the values in the name column, but do it in descending order from the end of the alphabet to the beginning, we can customize and modify this argument from true to false. So now we're going to get a new data frame sorted in descending order, the end of the alphabet all the way to the start of the alphabet. Here's another example. Let's say I want to sort the values in this data frame by the platform, by the actual video game console that it came out on. It's as simple as just using the same method, but providing it a different input. We now want to sort by platform. And we're going to see here, we're going to start with the 2600s and move up or down to the Xbox One. All right. A couple important things to note here that weren't mentioned earlier. This is a pretty big collection of data. We have almost 17,000 rows by 10 columns. So what Pandas is actually doing here is showing us the first 5 rows, then truncating or leaving out the middle, and then showing us the last 5 rows as well. All right. Now, the cool thing is each one of these methods that we've called so far produces a brand new data frame object. And that data frame object is going to have the same family or collection of attributes and methods as any other data frame. They're all the same fundamental data type. They're the same data structure. They can support the same types of operations. So I'm getting a data frame here, which means I can go ahead and do something like call the head method on the resulting data frame and get the first 5 rows of the resulting data frame that is sorted by the platform values in ascending order. All right, that's kind of how you start chaining along these operations to very quickly iterate and very quickly discover whether you're moving in the right direction as far as, is this method returning what I want? Is it in the right shape? Okay, let me edit it. Let me add on another method. Let me keep moving iteratively, step by step, towards the analysis that I want. And that's one of the benefits as well of Jupyter Notebook is we have a complete record here, if we choose to leave it, of all the steps we took to analyze the data set. So unlike Excel, where you kind of open it up and you're just left with this blank table of values with no context, here there's a story to be told. And in the context of the Jupyter Notebook environment, you can also do things like leave comments, leave images, leave videos, leave audio. You can even have interactive diagrams, where you can slide a scale and see something change on the page. There's all kinds of interactive widgets that are integrated. So your notebook becomes a story. It becomes an explanation and an analysis more than just a piece of columns and rows data just lumped on the screen. So we now know how to sort by a single column. What if we wanted to sort by two columns? So for example, what if I wanted to sort first by the values in the platform column and then by the values in the global sales column? So what I'm saying is I want to sort by these platforms first. I want to go for 2600 first, but within a value of 2600 for all video games that fall within that platform, within that higher level tier. For those video games, I want to sort them by global sales. And I want that process to repeat for every single platform in the platform column. So what we can do here is call the sort values method. And now instead of providing a single piece of text, a single string, I'm going to provide a list, which is marked with square brackets in Python. And I'm going to specify the columns that I want to sort by. So first, I want to sort by platform. And then after comma, I'll say that I then want to sort by global sales. All right. So this, by default, is going to sort everything in ascending order. So first up, the platform column is going to be sorted in ascending order. So we're going to see 2600, which is the number. Numbers come before text when sorting alphabetically. And then within each platform, you're going to see we're going to sort by global sales in ascending order. So our very first game of Super Baseball has the smallest amount of global sales within my platform of 2600. You can see here the values start to increase for the platform of 2600. And similarly, if we go down here, you can see for my Xbox One platform, the numbers here are increasing as well. So we've sorted by two columns.